Hello everyone. Welcome to this Android workshop for beginners, which is also going to be hands-on. And this is a collaborative display from Google Developers Group Mysore, Bangalore, and also a club called Developer Student Developer Student Club from VVC. And about these organizations, we conduct events like these every week so that people can learn more about open source technology as well as Google technology. And if any one of you are interested in conducting a session like these or talking about a technical talk or something, you can contact us. We have we have Ms. Usha Rangaraju, who is the chapter lead of three organizations, that is Google Developers Group Mysore, TensorFlow User Group Mysore, as well as Women in Machine Learning and Data Science Mysore. And you can contact her. I have displayed the information here. You can reach out to her on Twitter or LinkedIn. The links are given in the description below. And coming to GDG Mysore core team, these are the members right now, and we are a common team for three different organizations. That is TensorFlow User Group, WMLDS, as well as GDG. And this session, we conduct events on a frequent basis, like almost every week, with multiple events every week. And it's because of these combined efforts from all these members. So uh, if you want, you can also stay tuned with these links up here for future events. Please do be connected on our meetup links, which will be updated once in a while. And for this session, we have a community partner, Confub. Confub is a platform where you can uh, do a live stream like conferences. So I've put up the link in the description. Please do check it out. And without further delay, let's get started with today's session. Starting with the speakers. About the speakers, we have two speakers here today. We have Adith and Ruthvik. Both of them are Google certified Android developers. And Ruthvik is a fourth year undergraduate student at VVC Mysore. And Adith is a pre-final student at VVC Mysore. So let's get started. I'm going to hand over the session to Adith. Adith, can you share your screen?
Oh yeah, I'll share it. Is the presentation visible?
Just a minute. Yeah.
Okay, so hello everyone. So let's get started with the session. So first of all, many of you might have the question, why Android app development? So one of the primary reason for any software is market share, right? So Android comprises of around 2 billion devices. And so that is obviously something that you should look upon. Suppose you have a software model. And of course, there are various types of devices. There are mobiles, tablets, TVs, and wearables, Android Auto, that is for cars, as well as Android Things, that is used for your smart appliances. So there are a bunch of various platforms in Android itself that you can target for your particular applications. So coming to the content of the workshop, this is going to be the flow. First of all, we're going to start with basic user interface and designing. And then we are going to show what multi-screen applications are. And we're going to move on to database, or in particular room database, that is going to be using local on-device storage. Then we're going to look into something called Json parsing if time is available. And then finally, what is the MVVM design pattern? Okay, so for the purpose of this workshop, we're going to explain all these concepts using a to-do list app. So let's begin. First of all, user interface. In any particular application, the user interface or user experience plays an important part because that is how you interact with the app or any software or web page for that matter. So that is one of the key things that you need to look into, because if an app does not look good, you are very unlikely to use it further, even if it has wonderful features. Okay, so all of you head on to this link and make sure you download the repo. I hope you've already done that. And this contains two apps. One is the starter app that we're going to be starting with. And by the end of the session, we'll be approaching the same stage as the final app. Okay, so once you've downloaded that, make sure you open the app. So using Android Studio, just go to open and select the particular project. Just select the folder, don't need to go inside it. You'll get an Android icon like this. Click on OK, and it will load up. The first time, it will take some time to build, as it has to integrate all the components and set up the environment. So the first particular load might take some time depending on your system. So over here, we've already created empty files for all the particular tasks that we'll need to do. But suppose you're creating your own project, you'll just have an empty project with just a main activity and the activity main resource file. So Android or any application for that matter comprises of two ends. One is the front end and the other is the back end. So the front end is designed using XML and the back end is designed using either Java or Kotlin. For the purpose of this workshop, we're going to stick to Java. Okay, so I guess let's get started. So this is a general the basic template that is going to be given. There are a lot of different layouts that are used. So a layout is something that is used to organize or arrange different views inside a particular screen. So coming to what are views. So there are different types of views. Each element of your app or your UI corresponds to a view. It might be an image, it might be text, it might be buttons, it might be sliders, toggle buttons, checkboxes, radio buttons. All these are different types of views. So primarily for displaying text, we use something called as a text view. For taking inputs, that is in forms or search boxes and such things, we use something called as edit text. To display images, we have something called as an image view. And for buttons, there's a view called button. So these are some of the basic ones. So coming to layouts, there are multiple types of layouts. There's linear layout, then relative layout, constraint layout, coordinator layout, and there are multiple more. But the main or commonly used ones are constraint layout. But that is slightly a complex concept. So we'll start off with something called as a linear layout. Linear layout, as the name might suggest, it stacks the views linearly, either horizontally or vertically. That is, if it is horizontal, one next to the other. If it is vertical, one below the other. So say a simple example might be your contacts app. So if you open your contacts, the list of contacts are displayed one below the other in a linear fashion. So that will be your linear layout. So let's I'll just show you a quick example. So by default, the app uses constraint layout, but if you want, you can always change it. So I'm changing it to linear layout over here. Okay. So like I mentioned, there are two types of linear layout, either horizontal or vertical. Horizontal is one next to the other, and vertical will be your views will be stacked one below the other. So for this, let's just keep it as what do you say, vertical. Let's switch to this one. So the parameter will be orientation and just select vertical. As you can see, it automatically suggests possible options, so you need not remember the entire syntax by heart. Okay, so there are two types that you can use to design it. One, you obviously have your design view, or you also have your code view. So I'll just show you the code part for now, and later we can use the design part. So let's just say, okay, coming to our app, we have multiple views, right? So a to-do list app will commonly have, say, your list or list of to-dos, and there should be an option to add your or add new lists or new to-do tasks, as well as an activity to view your tasks. So let's just take the activity example. So where we need two views for inserting, that is the title as well as the content. And then let's say we have something called as priority. So let's just start with an edit text. So edit text is used to take input from the user. So as you can see here, you have something called as width and height. These are for the dimensions. And as you can see, I've used two separate options over here. One is match parent and the other is wrap content. So what do these mean? Match parent means your particular view will match the size of your screen. So in this case, the width will be, or the width of this view will be the width of the screen or the parent layout. And the parent layout, as you can see, matches the parent, or in this case, the size of the screen. The second type is wrap content. So what wrap content means is it will only take as much space as is required by the content of the view. So in this case, there's just one line. So it will take how much ever space is required for that particular line. So to reference objects between your front end as well as back end, we use something called as IDs. So let's just give an ID. So this is going to be our title. So let's just say title TV. So TV stands for, sorry, title ET. So title ET stands for edit text. Just a minute. Okay, I hope it's visible now. Okay, we have our ID, that is title ET or edit text. And then say we want to display a hint, that is what the user should input over here or what the user should enter. So here, let's just say title. So what this will do is it will just display a hint over here. And as soon as the user clicks on it, that hint will disappear and whatever text is entered, that will be given. Now, as you can see, this is completely to the edges of the screen. But if it is so, then there might be some issues. It is not very clear, right? So suppose we want some margins around. So we use something called as layout margin. And let's just say 24. Okay, so there are two new things here. One is margin and one is your the units that I've mentioned here. So first I'll take up what margin is. So if you can see here, the outline for the particular view is there, and there is some space that is given outside that. So that is what margin indicates. So this is the space outside the view or between views. There's another attribute called as padding. So what this does is there will be space that is being generated or given that is within the view. That is within this box that is there, there'll be some space that is going to be given. Next, coming to the units over here. This is something called as DP. So this is density independent pixels. So there are various types of devices, right? Each device has a different screen size as well as a different resolution, which in turn means a different pixel density, that is number of pixels per square inch. So what happens is, suppose I mention the units in pixels, then suppose on a screen with a larger pixel density, the UI will appear very small, whereas on a screen with a lower resolution, it will appear very big. Now, for example, what just happened? Now, the screen resolution on mine was pretty high, so the text was very small and it wasn't clearly visible. So you don't want that thing to happen, right? So for that, we use something called as DP. So this will automatically adjust the size based on the resolution as well as the screen size. Similar to DP, there is something called as SP. So SP is used for text that again scales it accordingly so that the font size is uniform. And also, suppose the user chooses the system-wide font size as small, medium, or large, it will automatically scale it accordingly, and it will leave the UI as it is. So here you can see there's some a warning that's been given. That is because I've hard-coded the values, right? It shows hard-coded string. So why this is happening is because suppose you're building larger applications where you have multiple text fields that are there, and there are multiple or lots of text that is being there. And say you want it to be there in different languages. You can't manually go and change the value of each text each and every time, right? So what we do is we have some file called as strings.xml. In your resources, in the values package, you'll have something called as strings.xml. So what we can do is all our strings are going to be stored over here. As you can see, for this particular app, we've already done that. So whenever you want to change something, if I change it over here, all the places where the string is being used, it will automatically change. So say I have multiple languages that I want to support, I can have one strings file for each of those languages. And whenever the user switches the language, it can use the appropriate strings.xml file. Let's just go back here and say to use your string from the strings.xml, you'll use @string followed by the name of the string. So as you can see, title is already appearing over here, and that gets rid of our warning. Next, we need one more edit text. Again, width is match parent, height is wrap content. I need to give an ID. So this is going to be our description. Again, let's give a margin over here. Okay, now you've seen that we were coding each and every aspect, but there's also the UI part. So you can always just drag and drop your elements and change the values over here itself. So I'll just show you for the next two views. So we have our title, we have our description. Now we need our spinner, or what we're going to use to assign priorities. So what a spinner is it's basically a drop down menu. So you can just search and it will show you the view. And then you can just drag and drop for the position. Since it is a linear layout, it will just stack it one below the other. Suppose you don't want to use the code part at all, you can just switch to the design view and you can click on attributes tab over here. And this will show you the list of all the attributes that are available for that particular view. And you can go ahead and change things over here. So let's say I want to change the ID. I can just go to, say, priority spinner, and that will automatically change. Like say layout width is already there, height, other things. So you can just search over here for a particular attribute. Let's say margin. So I can just enter over here and it will automatically apply. Okay. So now that we have these three done, we are going to need a button for submitting or saving it, right? So let's use the UI again. Just drag and drop. It will insert it. And you can either use this attribute pane or you can use this. This is submit. Let's give a margin again. So as you can see, with a few lines of code, we were able to generate the UI. All these are automatically or inbuilt, so you don't have to do much effort. So I guess this part is now clear. Let's move on to the main activity over here. I'll just switch this back to constraint layout. Okay, before we, let's just get rid of this for now. So for our main activity, we need the list of all the tasks or the to-dos. So to display a list, we are going to use something called as RecyclerView. So let's just enter this in. And unlike what do you say, linear layout, constraint layout uses something called as constraints to define the position in the particular activity or on the screen. So how this is better than linear layout is this automatically adjusts based on your screen size. So if your screen is bigger, it will automatically space things out evenly. Whereas if it is smaller, it will adapt to that particular constraint instead of mentioning a fixed size. So here I've given match parent for now, but you can see over here there are 4 dots on either edges of the particular view. So these are for the constraints. So this is to constrain the top, left, bottom, and right. So the top and bottom are to constrain it vertically as to determine where it is going to be on the screen in the vertical position, and these two are used for the horizontal position. So let's just constrain it. If I just click on this, what happens is it constrains it to the edge of the screen. So suppose this screen extends horizontally or vertically, that will automatically adjust accordingly. Now in this case, it is the same size as the parent, or it extends the entire screen, so there won't be an issue. But say for other cases where there are multiple views that need to be arranged, then it will obviously help with such views. For it to be constrained, we just enter 0 dp over here for width and height. So what this means is the width and height is gonna match the constraint and not a particular fixed dimension. Next, I need to explain what is RecyclerView. Correct. So obviously, you know that whenever we have to display something, there is going to be data that is required, as well as resources that are going to be used to display the data. Correct. So suppose I have a list of say 100 contacts. If I have to load all the 100 contacts at once, then obviously the CPU and the GPU is going to be utilized more because it has to render all of it. And then there's also going to be RAM usage because it has to store all of that in memory. But to eliminate that particular task or that particular problem, we have something called as RecyclerView. So what this does is it generates only as many views as can be fit onto the screen. So whenever you scroll, the new views are going to be generated and the old views are going to be recycled. So that is why the name RecyclerView is being used. So just to explain over here. So you have your RecyclerView. You have something called as adapter that is going to provide the RecyclerView with the data, as well as a layout manager. So layout manager is going to be used to define what type of layout or how the data is supposed to be arranged. So you can either have a linear layout manager, like how it is in your contacts, or something called as a grid layout manager. Say your gallery or your photo gallery uses that kind of layout manager. So next, we're going to use something called as a floating action button that you might have seen in your contacts app or your dialer, where the center, generally it shows the recent contacts, and there's going to be a center button that is floating or hovering above the background text. That when you click, it performs a particular task. So the floating action button requires a particular icon. So in this case, we've already added an icon that is IC add black. So I'm just going to use that. So as you can see, it's appeared. Now I want this in the bottom right corner. So what I can simply do is just align it to the right and then to the bottom, and automatically it is going to be aligned. Now, irrespective of how the screen size changes, this will always be aligned over there. Now, let's say I want some padding. This is too much to the side, right? So let's just add or shift it a bit. So I'm going to add a margin of, let's say, 24 dp. So as you can see, it is 24 dp above the base and 24 dp to the left of the right side of the screen. Okay. Now we have our RecyclerView ready as well as our add activity ready. Now we need For our recycler view, it uses something called as a list item. You can see it is showing over here, right? 0, 1, 2, 3, so on. So we need to define a view or a layout that is going to be rendered multiple times inside this recycler view. So we call that as a list item. So we need to define that, or we need to create that. So let's just do that. So again, we have our constraint layout. So for this, I'm going to need two text views and I'm going to need three text views. So one is for our title, one is for our description, and one is going to be for our task priority. So let's just change the dimensions quickly. I want the width to be same as the screen, but height to match the parent. Sorry, wrap the content. So looking at my text view, as you can see, I've constrained it. Let's give a margin of 80. Now say I want to change the text size. There's an attribute called text size. And here you're going to mention the dimensions in SP so that it scales accordingly. Similarly, if you want to change the text color, there's another attribute called text color. And here you can mention the color in one of two ways. One is either use the default colors that are there in the Android OS. So for that, I'm going to have to use something like Android color, and say there are multiple default options. That is colors itself like black, gray, so on, as well as default colors that are going to be used in general for particular or in different scenarios. So your primary text when it is in light mode, your secondary text when it is in dark mode, secondary text when it is in light mode, and so on. This is one particular method. The other one is you can either hard code the value over here, or else you can define it in your colors.xml. For both of these, you're going to need your hex code. So a hex code is something that comprises of three values, that is your RGB values in hexadecimal numbers. So it goes from range of 0 to 255, or in hexadecimal 0 to FF. So it takes in six digits or six hexadecimal digits preceded by a hash to indicate hex value. So let's just say this indicates black, 000, or 6 zeros indicates black, whereas 6 Fs indicate white. So they correspond to the red, green, and blue values for the particular text. So the first two correspond to the red value, the next two correspond to the green value, and the last two correspond to the blue value. So I can either mention it here, or suppose I'm going to be using the same color multiple times, then I can define it in my colors.xml. Say something called color, text color, and let's say so what I can do is I can just reference that over here. Add color slash text color. So it can be done in either way. Next, we're going to need our description. So similarly, another text view. So as you can see over here, I have constrained this to display below title TV or the title text view. And as you can see over here, layout constraint top to bottom of. So the top of this text view is constrained to the bottom of this particular text view or this particular view. So this makes it easier, so I don't have to manually create a bunch of views. Now suppose I had to recreate the same thing using say linear layout, then I'd have to use a vertical linear layout over here. But suppose I wanted something onto the right side, then I'll have to use a combination of vertical linear layout as well as horizontal linear layout. For something as simple as this, it is not so difficult to implement it using linear layout. But say something like your App Store, which has a combination of uh, horizontal scroll views as well as vertical scroll views. It has multiple images and a lot of complex views, right? So in such cases, it becomes very tedious to implement it using linear layout. So for that, we use constraint layout. So let me just give some margin over there. Mention the text size, and you can also mention the text style. So this is bold, italics, or normal. So let's just try out italics. And then say, suppose you want your text to be either to the left, right, or if you want to use different text alignments, there is something called text alignment. Here you have multiple options: center, gravity, view start, and so on. So what this means is view start is the start of the view or left align, and similarly have multiple options. View end is to the end of the view or right align, and center is center align. The others are similarly but slight different variations of the same. So you can try it out later. Okay. So next we need our priority. So another text view for the same. Okay. Now I want this to my right. So I'm just gonna do this. And let's give a margin. Okay. Now say I want my text to span whatever possible length it can. So I've constrained it over here. So but what happened is it has just centered it because it is using a different type of constraint. So it is using wrap constraint. But the same thing, if I change it to match constraints, you can see it matched the constraint. Now, as and when the views change or the sizes change, this particular view will also change based on the constraint. Similarly for this, I can either double click over here and change it, that is toggle between wrap content, fixed width, or else match constraint, or else I can just toggle it over here by changing it to 0 dp. So you can observe this spans the entire width. So now our list item is also done. So let's just go to the main activity and let's mention list item. So this particular line, what I'm adding is not required for the final app or not required for the code to work. This is just so that we get a visual representation of how it is going to look. So this is how it's going to look. So whatever is prefixed with tools, okay, that is not going to be rendered in your final app. It is just for your reference that is going to be used inside the coding environment. Okay, so now that we are done with our front end or our views, let's shift focus to our backend. Okay, coming to multi-screen. Multi-screen means obviously your app won't be restricted to one particular screen. You'll have multiple views that you want or multiple screens for or to perform multiple tasks. So for that, we are going to handle it differently compared to single views. I'll show you exactly what we need for multi-screen in a bit. But now let's shift to the database part. So database uses something called as architecture components. So Android architecture components are going to be used. So there are three particular components that are going to be used for this particular app. That is room database, live data, and ViewModel. So coming to room database. So room database is a local storage or on-device storage that is going to be used. Uh, it is an abstraction over SQLite database. So instead of manually typing the queries or writing the queries, this abstracts a lot of concepts and makes it simpler. Next is live data. So what is live data is many times you have data that is being displayed on your screen that needs to constantly change whenever, say, your database changes. Now, say your contacts, for example, or your task. As soon as you edit it, you want that change to be reflected on your screen. And you don't want to wait until you close the app and open it again for that change to be visible. So for such scenarios, we use something called as live data. And coming to ViewModel. So in Android, we use something called as the MVVM design pattern. So what MVVM stands for is model, view, view model. So as you can see in this diagram over here, model refers to your data or how the data is being stored. It might be either local data source or a remote data source. That is, you're storing your data locally on device or say on the cloud and fetching it using some API. Next, both of these are passed on to something called as a repository that hands over the data to different view models. I'll touch view models in a bit. And finally, in the end, we have something called as views that finally display the data, correct? So I've covered model and view. View model is used to interact between the two. It's going to fetch the data and display the appropriate data or pass on the data to the views. Now what happens is for each activity, we create a separate view model. Why this is done is because for one, each activity might request the same data or it might request different data, correct? If I have everything in one, then I'm simply creating multiple instances of that view model and it just takes up more resources. And in case where two activities or two activities are using the same data, if I make change in one, that might not be inflicted or that change might not be visible in the other activity and it might create a crash in the app. So we separate the views and the view models. Next, we use something called as a repository to interact between the data or the database as well as the view models. So the repository is going to fetch the data from the database and pass the respective data to whichever view model requires it. So this is the current pattern that is being followed in all Android apps. So let's move back to the code. So first of all, to start with room database, you are going to need to include the dependencies. So like how in other concepts you have libraries, in this we call them as dependencies. Now for the sake of this workshop, we've already added them. But suppose you need to add them, then you can always Google it and you can find the that is the particular thing. So you'll have to go to something called as Maven repository from Google. And if you type in the particular library that you want, you'll get the code for it to copy and paste it over here. And once you're done, you need to sync it. Do not, you need to add it in your build.gradle file, that is for your app module. There are two build.gradle files. One is for your project and one is for your app. You need to add it in your app module. So once that is done, you need to sync it. So this generally takes some time because it has to download the required components and sync it with your app. Just close out this. Okay. So first of all, in the room database, we have multiple components that you can see. As you can probably see from the files that are created, there's something called as task, task.dao, database, repository. So first is our task or our entity, that is the data that we want to store. So to link this with databases, database concepts, an entity, or as we call it in Room, is or symbolizes your table in your database concepts. So to make sure that this particular class is an entity, we use annotations. So we're going to use the @entity annotation to mention that this particular class is going to be our table. And you can also mention a table name. Suppose you don't mention the table name, then you'll have to reference it using the class name. Okay. Moving on. All tables or all entities require something called as a primary key to uniquely identify it. Correct. So again, we're going to have a primary key in R2. Okay. So I've created a private variable called task ID, and I've annotated it with @primary key. And I've also mentioned something called as auto-generate equals true. So what this means is I need not manually enter the ID for each and every insertion. It will automatically update it on its own. So it will start from 0, and as and when new entries are created, it will keep on incrementing it. So I need not worry about that. So next, say I need to store my title as well as my description. So let's just add that. Again, like how we annotated the class name with table name, you can also use the same for the variables, or these will be your attributes. If you were to link it with tables, then these would be your columns. So suppose I want the column name to be different from my variable name. I can use something called as common column info name, and I can mention a different name over here. So our priority is going to be of int data type. So next, we obviously need a constructor. Okay. So you can either manually do it, or you can go to code and implement methods. So the shortcut for that is Control I. So because this doesn't have any mandatory methods to implement, that won't be there. But you want to generate it manually, right? So that is going to be in the generate tab. So Alt plus insert, and it will show you what you want to generate. That is a constructor or getter and setters. So first we're going to need a constructor. You can select all the attributes that you want to include in the constructor. So I've selected all of them. And next, I'm going to need something called as getters and setters. Again, I'm just going to do it for all of them. I'd suggest to use the automatic generation than you manually typing it, because sometimes it might not detect it. So here, getter and setter is going to be used whenever you want to fetch the ID or write to it. So getter is when you want to get the value, setter is when you want to set or update the value. Now, now that we have done our task, to write our queries, that is how we're going to fetch the data or write the data onto the particular table, we have something called as DAO. So as you can see, there's a task DAO over here. So DAO stands for Data Access Objects. Okay. So for this case, we've already done it. I'll just explain what it is. So first of all, this is going to be an interface. And like I mentioned, you need not always write the queries. You can just use the inbuilt annotations. So for inserting, you can just use the @insert annotation and mention a function. So obviously we need to pass the task that we want to insert, that we're going to pass as the variable. Suppose it is going to be returning something, then we're going to mention it over here in the return type. For insert, there's no such return type. So you can name the function whatever you want, annotate it with @insert. Similarly for update as well as delete. And then suppose we want to fetch all the data. So for that particular case, we need to write our query on our own, because uh, we might want to fetch different attributes, not necessarily all the attributes. And there also might be separate conditions that we want to apply while we're fetching the data. So in such cases, you use the @query annotation and you write your regular SQL query. So select star from tasks. So select all the attributes from the table tasks. And this might be something new that you've come across. So data source dot factory, so on. This is so that we return a, this is the data type, or what is going to be used to return live data for our page list or paging adapter. That is going to be explained later. So don't worry about that. What this basically means is uh, what we are getting a data where we are mapping integers to tasks so that in a list, these integers are going to be used to index it, and these are the tasks that it is going to be mapped to. Don't worry about it. We'll explain it in detail later on when we come to the adaptive part. So now that the DAO is done, let's move on to the database. So like I mentioned, your entity or your data corresponds to one particular table. But in a database, you will have multiple tables, correct? You might have multiple tables. For our particular case, there is just one, so that is fine. But in case you have multiple tables, then you need one common point where you can access all of them. So that is where we're going to use our database. Okay, so for this, annotated with at database, and we need to mention the entities. So in this case, there's just one entity. So task.class followed by the database version. So database version 1. Export schema, you can leave it as false. So version 1 is because why you need versions? Of course, suppose say you add some features later, or say you want to add say images as an option later on. So obviously your database or your entity will change, right? So in such cases, to avoid clashes, you need to update the version. So version 1, 2, 3, so on. So in the database, you're going to need an abstract function. I'll explain that later. And what we're going to be using is we're going to ensure that there is just one instance of the database that is going to be generated. Why this is because if there are multiple instances of the database generated, then obviously while writing and reading, when one instance is writing, there might be another which is reading, and the data might not match, and this might lead to crashes in the app, which we obviously don't want. So we're going to ensure that there is just one instance that is being generated at a time. So this particular variable is going to hold the instance of the database. And to ensure that there is just one instance being generated, we're going to use this particular function. So context is used to determine or to understand where the call or the function call is coming from. So which activity or which say resource is calling this particular function or wants this information. So to make sure that there is just one instance, let's first have a null check. So only if it is null, then I want it to execute. If it is not null, I'll just return the instance directly. Okay. So in the case it is null, I need to ensure that that particular part is the only one that wants to create an instance. There might be a scenario where multiple activities are requesting for a new instance of the database. So I'm gonna synchronize this class to ensure that there is just one call being made at a time. And then I'll again ensure that it is null. Now, once this is done, then I can build my instance or create my instance. So for this, where this task database belongs to something called as room database, right? That is what we're going to be using. So this extends room database. So to create it, we're going to be using something called as room.database builder. And as you can see, it takes in some parameters. So context, we pass it. Then the database class, this case, task database dot class, followed by the database name that we want to give. So let's just say task database. Now that this is done, let's we need to build it, right? So this is done. But before we build it, we need to ensure that whenever there's a transition in the version, we need to have some mechanism where the older database gets migrated to the newer database. So the simplest way is fallback to destructive migration. This is not the optimum, or this is not the ideal way to do it, because what happens over here is whenever a new version of the database is created, the older database is overwritten with the new one. So what happens is all the data that was there in the previous database is lost, and a new instance of the new database scheme is going to be written. This is not what you want to use in your production level apps, because then the user data is lost forever. So database migrations is an advanced concept that you can look into later, or maybe we'll cover in a further session. Then suppose I want to execute something as soon as the database is created. Suppose I want some pre-populated data. So how do I do that? So for that, we add something called as callbacks. Add callback. New callback, and you can have a callback for any of these three tasks. So any of these three conditions, rather. So one is when the database is created, the other is when the database is opened, and the third is when the database on destructive migration, that is, when the database is being overwritten. So pre-population is obviously in onCreate. So let's just do an onCreate. So whatever pre-population function that you want over here, or however you want to insert the data priorly, you can mention over here. This particular part we're going to explain later on. So I'll just leave this as it is for now. So once this is done, we're going to have to look into our repository, like I mentioned. So for repository, what this basically does is it takes the data from the database and passes it on to the respective view model. Now, suppose a particular activity is requesting for a particular data that gets passed on to the view model, which in turn makes a call from the repository. And the repository, if it has it, then it passes on the data. Else, it makes a query to the database, which in turn fetches it from the respective entities, and it gets trickled forward again. Now, the repository concept is going to be explained by my friend Ruthvik. So let's just take a 5-minute break over here, and you can have a look at these so far. And if you have any doubts so far, you can feel free to ask.
Will you be taking the doubts right now or at the end of the session?
If they have any doubts in the code so far, they can obviously ask it now. Else,
Well,
we
I
can
don't
take it
think
up
they're
later as
coding
well.
doubts, but they have like general doubts about Android.
Okay, I guess we can take whatever is already posted. I see
Okay.
a few posted.
Um, okay, I'll start popping one.
Okay, so which should I focus on, Java or Kotlin? So currently, uh, you can say Google is pushing towards Kotlin, but a lot of concepts, or as you might have known, Kotlin works on the Java compiler, or it is built on top of Java. And there are a lot of similarities as well as a lot of differences. But I would say you can start off with Java because many of the current apps are still built on Java, and it is mostly the newer apps that are being built that are on Kotlin, and very few are migrating towards Kotlin as of now. So I feel at least until the basic part, that is room database and some other basic concepts, you can go through in Java, and then for the advanced concepts, you can migrate to Kotlin later on.
Okay. Yeah, one more doubt. It's not exactly a question, but I think you can give him a tip or something.
So for ML models in an Android app, there's obviously TensorFlow Lite that is being used. So you'll have to write your particular model using TF Lite and then import it. If you want to go through, there are a lot of code labs that are being given by Google. I guess we can share a link later on in the description or something like that. So you can go through that for implementing ML models.
Okay, one last question.
Okay, yeah, this is the same code that is being that is there on GitHub. So the starter app is what we started with, and the final app will contain the final code that is going to be that we're going to reach at the end of the session.
Okay, that's it for now. We'll take a quick break. For those of you who are watching the video, if you want to skip the break, just fast forward for 4 or 5 minutes. That's it.
Kevin, I think I can add more to that second question
Oh yeah, sure.
regarding machine learning. Yeah, so basically, TensorFlow or ML, if you are a beginner in machine learning, you can visit TensorFlow Hub, where they've given a lot of pre-trained models. So especially the models that work well with mobile devices or web, these kinds of models are present there. You can take a look at that. Or if you have your own custom model, you can, and if you are willing to work on-device machine learning, then in the new version of Android, that is Android 11, and in the new Android Studio, they've made a lot of changes to help developers work with machine learning. Like Adit said, you have options to create or import ML models, that is TensorFlow Lite models, into your Android app. And with Kotlin, I think it becomes very less code. I think probably 4 or 5 lines of code would be enough. And also there is a MLKit SDK, a new SDK that has been released. You can use that also. There are a lot of object detection and object tracking models. A lot of things are there. You can take a look at that as well. And if you want to work with a custom model that is hosted somewhere, then obviously you have Firebase to store all your models, and depending upon the regions, you can alter the models. So yeah.
Thank you, Ruthvik. So we'll take a quick break and we'll come back later.
Hello, everyone. I am Ruthvik B.R. I'm an undergraduate final year student from Vidyavardhaka College. So I'll be continuing the next part of the application development process. So let's have a recap before we start. So the very first part of our building your application is to describe or design your user interface and how the layout should look. So for that matter, we made use of XML to design the code. And for the logic part of the application, we are making use of Java. And talking more about user interface designing, we came across different kinds of view groups or layouts. We also came across different kinds of views. So, in brief, or in short, views are whatever you see on the screen, and the way that they are organized it entirely depends upon the view group or layouts. So, if it's a linear layout, all the views will be arranged in a linear fashion. If it's a relative layout, then the views will be arranged with relation to each other. If it's a constraint layout, it will be it will be constructed with some sort of constraints. So the reason constraint layout is being used everywhere is because it is a responsive layout building. So if you just try out building using a linear layout, what will happen is in one screen or in the screen size that you are designing, it might look proper, but then if you switch to a different screen width or a screen sizes, the layout will look a little different. So that's why we make use of constraint layout. So after that is done, we came across the code. For now, for this, for the purpose of the workshop, we have two different screens. One is the list, the main activity that displays all the list of tasks that we have set for ourselves, and the next screen is is the one where we add the tasks. So to add a new task, what all we need, that we have to design there. So firstly, we needed a title for the task. After that, a little short description and a priority. So priority, we made it as a spinner or a drop down in order to set the priority. And we are making use of three different priorities: uh, high priority, medium priority, and low priority. So for that case, we are making use of a spinner. And then to submit all the data, we're making use of a submit button. So once that is done, we came across the recycler view. So before we go into recycler view concept, I'll just uh, explain it to you. Like, suppose there is a contact and you have to load, and you've constructed or you've designed your layout in such a way that there are 100 different text views to add the name and phone number of 100 different contacts. The drawback of this method is that it makes use of a lot of resources in your memory, right? Which is a bad which is a bad application development process. So that's why what we've done is we've made use of something called as recycler. So what recycler view does is it takes a template. In our case, it's the list item layout. It takes the template and it repeats that template only as much as the screen sizes. And the data is loaded only for those templates. So we don't have to load the data for the entire text views, and even the code, the size of the code becomes very small. So how this works is, as you can see in the picture, the data source here is our database. There is something called as an adapter. So the purpose of the adapter is it creates new views and binds the data to the views. The view holder is something that creates or inflates the list item or the template view that we have, and it generates as many views that we need. And the adapter receives the data from the data source or database, binds the data, and then displays. So this particular adapter we are using with the recycler view. So in the next few minutes, you'll see how to set the adapter, how to get the adapter, and how to add it to the recycler view. And layout manager is pretty simple. There are a couple of layout managers like linear layout manager and grid layout manager. These layout managers just uh, arranges your views according to whatever you are using. If it's a linear layout manager, all the views are arranged in a linear fashion. If it's a grid layout, it'll be a grid. So come after that, we studied about database. So before we go into database, I'll talk about the data flow. So MVVM is a four-tier architecture that comprises of a data source or database. We are making use of for something called as room database. Let me tell you now itself. In Android, we used to make use of two different kinds of databases. One was a SQLite database. The other one is room database. The reason why we don't prefer a SQLite database directly is because there's a lot of boilerplate code that goes into it. And room is one such library that reduces all that boilerplate code, and it really makes it very simple. So that is the first part of the uh, architecture that we have completed until now. So then there is something called as a repository, view model, and activity or fragment. The last fragment called as activity slash fragment. This tier it only deals with UI, so it only receives data from the view models and then it will display. In turn, view model receives data from repository, and repository in turn receives from the database. So let's say we are inserting a new task into our insert methods, one in the room database and one in the view model. And coming to the live data is a life cycle aware component. Like Adit said, if suppose a change has happened in the database or some value, it has to be updated to the activity directly. Okay, we can't keep querying the database for updated values. So in order to restrict that, we made use of live data. Live data, what happens is if a value is updated, that change will be directly reflected in your UI, right? So this is how the data flows. So let's start coding now. Let's first go to the repository. I hope you all can see the screen. So until now, we've uh, done till the entity class, which is a template for your database, which contains all the columns that you need. You're using an ID for a task, title, description, and priority. And we're making use of at column info to mention the column names in the database. And we have primary key to annotate a particular column as a primary key. And auto generate is equal to true. It automatically generates your primary key for you. And you have to annotate your uh, this Java class as entity class so that the database knows. And we've also given a table name. So that is what your entity class. And the next step was task database. We should be having only one instance of a database so that there isn't synchronization problems. So what we have to do is we have to mention it as an abstract class and extend the room database and annotate it with at database annotation. At this annotation takes three parameters. One is the entity class and a version number and an export schema. If suppose your app is already in production and you have made some change later on and you don't want to lose your users again, so you'll just have to mention your entity class as true. Only then you can make those changes. For the purpose of this annotation, we don't have anything like that. So we've set it as false, and this is the version 1. suppose there are different tables in your app, then you can just add a comma here and use that. Right? So in the task database, we first take an abstract instance of the task tower, and then we take an instance of this database itself and set it to none. The reason is because before the creation of the database, we just need one instance of the database. So what we do is in this get instance method, we are returning a task database here, and it takes context as the parameter. So firstly, it'll check if the instance is null. If it is null, we'll synchronize this class, task database.class. This is made to ensure that there is only one instance of the database running. So again, if it is null, we'll build the database using database builder, which takes three parameters. One is the context, and the next one is the database class, and then the database name. So like Adit said, if you have to perform any task when your database is being created, we add a callback. So in this case, we're making use of onCreate, inside which we have this particular set of code. Inside run, inside this onCreate method, we can write code to pre-populate the data. We'll do this at the end of the session when Json parsing comes into picture. So, and then after you're done with add callback, you have something called as a fallback to destructive migration, and then we'll build the database, and then we'll return the database that has been constructed. So I hope this particular, until now, there are no doubts. So we'll head on to the task repository. So basically, in this repository also, we'll follow whatever we've done until now in the task database class. So firstly, we'll need an instance of task DAO, or task database data access object. So private task DAO, and we'll create an instance of that. After which we'll need a instance of the repository. So static repository. So we'll set it to null because we need only one instance of this repository. After this is done, we'll be making use of something called as a staging list adapter, which I'll explain you moving forward. For now, we're making use of something called as page size. So after this is done, we'll be making use of something called as executors. In task database, you would have seen something like this: public static, private static, executor service, executors.new single thread executor. Basically, what we are doing here is in Android, we cannot access the database, or we cannot make a network call from the UI thread. The reason is because if you make a call from the UI thread, it might take a couple of seconds for you to get the data, during which your UI might get locked. So this particular is a really bad practice, and users should not do that. So that is why we are making use of a background thread to run the operation. So we'll create something similar to this private static executor service, and then we can make use of background calls. Executor handles that for us. After this, we'll need a constructor for this particular task repository. We are doing this because there are different view models in our application which makes use of this repository, which needs to get access to this. So we'll create a constructor and pass application as a parameter. Inside this application, what we'll do is we'll first define the task database. Like I said, repository interacts with the database and in turn reacts with the DAO. So any operation that exists there will be taken care of repository. So task database dot get instance, the method that we created, and pass the application as the parameter. And from this task database, we'll take a reference for the task DAO. So db dot task DAO. So once the constructor is ready, we'll next move on to the getting the instance part of the repository. Similar to the method that we created in your database file, static task repository is being written, get task repository method. Again, this method takes a application parameter. So first we'll check if the repository is null. So if it is null, we'll synchronize this class. So then if it is null, we'll construct the repository. And pass the application. As you can see, we are receiving application as a parameter for this method, which will be called from different classes. And then we are making use of the task repository constructor to get access to the database and the DAO. And in the end, we'll return this task repository. So once this is done, we'll need to create methods for insert, update, and query, and delete as well, right? So like I said, there exists 3 different versions of insert, update, and delete and querying methods. In firstly in a DAO, and the next one is in the task repository, and then in the view models. So we've already created the methods in task DAO, this interface, where we've annotated with an insert, update, delete, and query. Just one more tip, you can have as many query as you want for beginners who might confuse. You can have as many as queries as you want. You can change this particular string, and you can use different kinds of query methods on your database. And so let's start building those methods. So firstly, we'll create the insert task method, which takes a task variable. So task is just our entity class that we've made use of, and it will have all the parameters that will go into the database. So like I said, when you are using your database, all the operations that work with the database have to be run in the background thread. So I'm making use of an executor here, and then like I said, there is an insert method in task DAO. So we'll call that method from there and pass the task as the parameter or the variable to that. So our insert task is ready now. The method in the repository is ready. Similarly, we'll have to create one for delete and update. We call the delete method now. So after this is done, you can call your just a second. Yeah. So after this, we'll go to the update method. Again, it will take a task value as a parameter, and it will be run in the background. And we'll pass the task variable to the delete update task method. So we've covered all the three methods. So let's see how we can query the data from the database. And mind you, we are making use of something called as data source.factory. So we're receiving the uh, data from the database in terms of data source factory. Okay. So for that, we're returning here a live data object with a list, and it takes this of type task. So this is the return value of this particular method. Then we'll add the name. So from the database, we're receiving data source, and we have to return a live data page list of type task. So to do that, we write return new live is list builder, which takes in the data source and the page size. And then we'll have to build the live data. So this single line, this line, what it does is it takes the data source and the page size. We mentioned the page size here as 15. So it takes the page size and then builds the live data object, which we will be using later in the view models to display the tasks. The next part is view models, view holders. The first task that we are doing is to retrieve all those objects from the database and display it in your main activity, which is this. So we've only returned a recycler view here. We haven't yet mentioned the connections to each of those, and we haven't uh, written code for view model or how recycler view works. So let's do that now. So the components that we need to build first is a adapter. We already have the data source, so and recycler view also. So we need to take care of an adapter and a view holder. And recycler view is already existing. We just need to display it, and then there is a layout manager. So let's start with the view holder, and then we'll go to the adapter part. So if you can go to your list package, there is something called as list view holder. In that, you'll have to write code for your view holder part. So list view holder extends something called as RecyclerView dot view holder, and you'll have to implement a constructor here. And inside the constructor, before you do that, you'll have to create the variables of your list item. As you can see in my list item, I'm having three different text views: priority, description, and title. So let's create those and take a reference for it first. So first is the title text view, and then there's a description text view, and lastly a priority text view. So to connect the XML code to the Java code, we'll be making use of something called as find view by ID. In this particular view holder, what we are doing is we are receiving an item view, which is basically a view, which will have these parameters. So we need to connect the variables to that. So we'll do something like title text view is equal to item view, which is being returned here, dot find view by ID. We're referring to the view here in terms of something called as an ID. So we'll be using the same IDs here. So r dot id dot id dot. So we'll be using the first is the title text view. So we'll call title. And you might get an error like this. So just click on Alt plus Enter. It will add resources here. So once this is done, just do the same thing for description text view. And then the priority text view. So we've taken references for the three different text views that are there in our list item. So like I said, a view holder first adds the data to it and then inflates it. So we'll create a method here to bind the data to it. So let's create that method, public void bind, which receives a single task object as a parameter. And to bind the data to your text view, we'll use the text view reference that we've created, title text view dot set text. And then if you remember in your entity class, there are getters and setter methods. So because the data is already being displayed here, because it's already being passed, we'll just get those values. And then description. The set text method takes a string as a parameter. So we'll call the string values. But priority is a different data type. So we'll have to convert it to string and then display it. So after this is done, your view holder part is ready. The next step is to use the adapter. For this particular project, we are making use of something called a paging list adapter. So before I start coding, I'll explain to you what a paging list adapter does. Usually your adapter takes the data source, all the entire data source, and then binds the data for each values, right? But then what if there are a lot of elements to be uh, binded and there's a lot of data coming in. So there will be what you can say a delay if regular adapter is used. You might have come across apps wherein if you scroll a little faster, it'll lag a little. So to avoid that, we'll make use of paging list adapter. So this particular adapter, what it does is it takes a portion of the database or the mentioned page size, and it only load as much as data as we mentioned. For example, in our project, we are mentioning 15 as the uh, 15 as the page size, a single page size. So only 15 elements will be loaded first, and then the next elements. As in when we scroll down, the next elements will be loaded continuously. So just a second. I hope the code is visible now. So yeah, we are done with your uh, list view holder, and we're moving forward with paging adapter. Right. So here you have to extend to page list adapter, which takes in two values as parameter. One is your entity class. Yeah. So one is your entity class, and the next one is your view holder. In this case, we've already created our own view holder. Let's use that. And there are a couple of methods that we have to create. And because we haven't written it yet, Android Studio is showing you an error. So those two methods are on create view holder and on bind view holder. So, and we'll also need a constructor here. So let's do that. So what this particular view holder does is once this inflates the layout list item layout, this particular file, it inflates it and then it displays it or inflates it and returns the view. And this particular bind view holder calls the bind method that we had written in your view holder, and your task gets updated there. So firstly, we'll have to inflate it here. So let's use layout inflated. Layout inflated dot from, which takes in context as a parameter. So we'll pass parent dot get context, after which we'll be creating a view that we have to return or send it to the view holder. If you remember, in your view holder, you are taking a view as a parameter, right? So we are returning that item is equal to layout inflated dot inflate. So this particular thing takes three parameters. First is your list item XML file that you've created. So r.layout.list item, and then it takes a view group or root. So let's pass parent to it. And then it'll ask if we want to attach the view immediately to the parent or later. So for now, we'll have to add the data. So we'll give false. And then while returning, we'll have to return a new list view holder, which takes item view or an item. So once this is done, we'll have to bind the data to it. So we'll take a task variable. And once it is to retrieve the task variable from the list of data, we'll call get item in the position. So as you can remember, it inflates each layout template and adds data to it. So you can imagine there are different uh, sets of items. So we'll receive one item in a particular position and then inflate it. So once we've received this, if the current task is not null, then we'll have to bind the data to it. So in the view holder, we had written a method called bind. So we'll have to pass the uh, current task to it as a parameter so that it can inflate it. Okay. So once this is done, we'll create something called as a diffutil callback. So once the paging adapter gets created, by default it is using a callback. If you want to use our own callback, then we have to create it. So to do that, we'll use private static diffutil dot item callback of type task, which is again our entity class. Give it a name callback. Then by default, it will create two methods. The items are the same and then the contents of the same. And it will compare these two methods. One is the task method. One is the, it takes two task items, old item and new item. And firstly, it compares the items and then the contents. Before we do this, we'll have to write a method in our task class. It's called as Boolean method is equal. So basically this method, what it does is it takes a second task object, compares all the values like title and description and priority, and returns true if and only if all these are, uh, you can say, different or the same. Okay, so we go here, and then we don't change the code. Okay, we'll discuss that later. For now, inside the R items the same, we'll check if the title is the same. Old item dot get title is equal to new item dot get title. So after this is done, inside the R contents the same method, we can make use of the method that we just created now and pass the second task object to it. So once this is done, we can make use of this particular diffutil item callback in our constructor. So just have to return, just have to call this particular thing there. So, and then this becomes useless. So we just remove that. So we're just mentioning our own diffutil item callback, and we've written the code how to check that, and we'll be using it on our constructor. So once your paging list adapter is ready and your view holder is ready, we can go to the view models and then your main activity. So like I said, your view model is your third tier in your MVVM architecture. And the reason why we use view model is to separate the logic from the UI. This is basically a code structure wherein the UI logic, everything that is being displayed is separated from the logic that alters the data. So let's start coding the view model now. So this particular view model, to make this class as a view model, we have to extend it. Extends Android view model, and then create the constructor. So from like I said before, this view model interacts with the repository. So we'll need a repository variable. So if you remember, to create a repository, we'll need to use the repositories get instance method. So we can do that by get instance, or even this works. Pass the application to it. So once this is done, this particular list view model, it only displays the data. So, and the data is in the form of live page list data, and it is in the repository. To retrieve that, we'll call public live data of page list, then of type task, and we'll give it a name as data. That should be it. Then it is like, a method in the task repository will return that source of data for us. So data is equal to task repository instance that we just created and get all tasks method. So that this particular code will return the what you can say the data source for our list, right? So, and also I said that we'll have multiple instances of the delete method and the insert method. So coming to the list, there are only three operations that can be performed. One is querying the data, and we've already done that here. Data is equal to task repository dot get all tasks, and there's one more as insert and delete, right? So in this particular project, what we're doing is, if suppose the user swipes the to-do list item, one particular to-do list item that he has completed, we have to delete that, right? So we'll need a delete task method, and we'll pass the task variable to it. And as you remember, in the repository, there is a insert method and delete method. So we can call the delete method from the repository and pass the task as the variable. Similarly, we can create a insert task method. So inserting task, although it is from a different different activity, we have one insert task method here. The reason I'll explain you further. What we are doing is, if in case the user deletes a task by mistake, we are giving him an undo option. If he clicks that, we'll again have to insert it back to the list. So that is why we have an insert task method in the list view model. All right. So we'll use the repositories insert method and pass the task variable to it. So once this is done, what we are left out with is to make sure that the data is being displayed, and we'll have to connect the data in the main activity. We've done with the data source, we've done with the adapter and view holder. So the next part is to create the recycler. You connect all the components in your main activity, right? So as you can see in your activity main XML file, we have a floating action button and a recycler view. So let's first finish this part first. We'll finish the navigating from one screen to another screen. In this case, the list activity or the main activity, which contains the list, from there to the new activity, adding a new task. So to do that, first we'll get a reference to the inside the onCreate method. We'll get a reference to the floating action button that we've created. We'll call it add button. Then, like remember, we're referencing to the views in the XML file using the find view by ID method and r.id. Add. So once we have the reference, we can use it. So here what we are doing is we are using listeners to it. So if that particular button or view is clicked, we can add a set on click listener. So inside that, you'll create a new view.onClick listener. If that view is clicked, this particular method will be called, and whatever code you write here will be executed. To navigate from one activity to another, we're making use of something called as intents. So to declare that, we'll have to write intent. Intent is equal to new intent, and we'll have to mention the source and destination. In this case, we'll have to mention the from where this particular intent is being called from, and from to where it's supposed to go. So we're calling it from the main activity, and we'll have to mention which particular activity we are heading to. In this case, it's an add activity. So we'll just have to write add activity dot class. So you can see a red line here. If you click on that, it'll show if you want to import that class. Press on Alt plus Enter and it will import it for you. So once this is done, we'll have to, if the button is clicked, we have to navigate there. So we make use of start activity and pass the intent. So if until now, what we've done is we've just added a reference for the navigation using the floating action button. Okay. So the next part is coming to the view models. Here we'll define few global parameters. The first one would be the view model. So private list view model. Create a variable for that, and we'll also create a task variable. So once this is done, we have to instantiate the variables. So view model is equal to create an instance of view model, we are using something called as view model provided. There is something called as view model providers, but that is old method. We are using this currently, right? So a new view model provided, which takes in context as a lifecycle owner, plus this here, and then we'll tell the view model provider which particular view model we are using, which particular class. So in this case, we are using list view model class. So we'll mention that. After this is done, we'll set up the RecyclerView and connect all the components. So RecyclerView is find view by ID dot ID dot. So to do list RecyclerView. So we have the reference for the RecyclerView. The next part is connecting the adapter to it. So we'll first create the adapter. Once the adapter is set, we can connect the RecyclerView to the adapter using the RecyclerView set adapter method. It takes an adapter as a parameter. We've already created one adapter, so let's just pass that. So after that is done, we have to set the linear layout manager. In this case, it is a linear layout manager. So new linear layout manager and pass this as the context. So we're done until displaying the items. So whatever data is there in your database will be displayed using this much code. So let's stop it here and we'll go to the add activity and we'll see how to uh, add data to the database. So before we go to the activity, we'll have to write code for the view model, add view model. So like we did in the list view model, we'll have to extend that data constructor, and inside the constructor we'll have to create uh, a reference to the repository and insert and delete methods. Okay. So let's create that. So you can just copy paste the task repository variable. Like that, you can write inside the constructor of the view model, you can write task repository is equal to new task repository and takes application as the parameter. Once this is done, you just have to use the in the add activity or the add screen. What you're doing is you either add a new task to the database, or you update the existing task in the database. So we'll have two methods here. One is insert task method, takes task variable. So then a update. So once this is done, your view model is ready and you'll have to work with your uh, add activity. So let's head to the add activity part now. So for this particular thing, we'll have to first take references to all the views that we created. 3 edit text, one spinner, 2 edit text, and a button. Right? And to populate the spinner in your strings.xml file, we've created a string array that contains 3 values of priorities, high, medium, and low. So let's see how to populate the adapter. So if you can go back to your add activity. Firstly, we'll mention the priority numbers, because in your task entity class, we are taking the priority in terms of integers and not strings. So let's create a integer array for that. Have three values, 1, 2, and 3. And then we'll set a default priority value as 0, in which case it tells people, it tells that there's no priority set currently, which can act as a check. So after this is done, you'll firstly take references to the edit text that you've created. So edit text. First one is the title edit text, or the task name or the to-do list name. Let's mention as title et, and we can refer to it using the find view by id method. Dot id dot new title. And then we'll get the reference to description edit text. New description. So these are the IDs that we had taken priorly, and to edit text other, then there's a button. We are naming it as submit button. Let's take a reference to it, r.id dot submit. So after this is done, we'll have to create the spinner element or populate the spinner element. So let's first create a variable task priority, and then we'll populate the spinner. Spinner is equal to find view by id, r.id dot the spinner id that we had mentioned. New priority. So once you receive the reference to it, what we have to do is we'll make use of an array adapter here to populate the spinner with pre-existing values. So let's use an array adapter, which is of type character sequence, because our in your strings.xml file, your data is in the form of strings here. So we'll create a array adapter of type character sequence. Dot create from resource, so which takes in 3 values. One is the context, and the next one is the ID of this particular array, r dot array dot priority array. You can make use of arrays.xml file also, but for this project we've defined that in the strings.xml file itself. So the other parameter is predefined inner item. So Android dot resources dot layout and simple spinner item. So your adapter is ready now. So what we have to do is we have to add a drop-down view resource. So the spinner that you created, no, not spinner, the adapter dot get drop-down view resource and a predefined view for that, Android dot r dot layout dot simple spinner item, simple spinner drop-down item. So this will populate the spinner with an existing array. So after this, we have to set this particular adapter to the spinner. So spinner.set adapter and pass the adapter that we just created now. And then we'll have to use the logic here is once the submit button gets clicked, the entire data should be retrieved from the edit text and the priority of the spinner, and then we'll have to populate it to the database. So to do the database part, we'll need a view model also, right? So let's create the view model reference here. And view model is equal to new view model provider. Takes this as a parameter and then gets the class. So add view model dot class. So we've taken a view model object. The next part is to receive the data from the views or receiving the user input. So let's we have to receive the data when the button is clicked. So submit dot set on click listener. So we'll create a new view on click listener here. then here we'll refer to it, right? So the first thing we need to do is get the strings from that edit text. So title is equal to receive to get the whatever text that has been inserted into the edit text. We'll use title VT, which is a reference to that edit text dot get text and dot toString. So whatever data is being stored here will be in the string format. The next part is a string description of your particular task or your 2D item. So description edit text dot get text dot toString. Once this is done, we'll have to check if the user has entered some values. For example, if the user hasn't entered any value and if he's uh, clicking on submit, we should not insert that to the database. Empty value shouldn't be inserted to the database. So we'll add a check here. So if title dot is empty, and we'll just add a not here. So if the title is not empty, and if the description string is not empty, then we'll have to create a new task object from the data that we've received. So this particular object takes 4 values. One is the ID, and then the string, title, description, and priority. If you remember in your entity class, we're mentioning the ID as auto-generate. So here we need specify the ID for this particular task object. We can just pass 0L as the parameter, and the database will create a new ID by itself. So, and then we'll have the title and description. And lastly, the priority. And then we'll have to call the ViewModel insert method. So if suppose the user hasn't pressed anything and is entered anything and is pressing on submit method, we have to show a value to the or show a message to the user saying, oh, please enter the data properly. So we'll make use of something called as toast. Toast is basically that short message that you get. Suppose if you have used Gmail app, when you when you send a mail, you'll get a message on the screen saying the email sent. So similar to that, we are creating one for this application as well. So we'll just write missed inputs. So whenever the user forgets to write uh, data into either of those uh, description or content and presses the submit method, this particular message will be shown to him. So once this is done, we'll have to see the logic is once the submit button is pressed and if the data is inserted, we'll have to close that particular screen. Once the new contact gets added, we'll close that screen and go back to the screen that we were before. So to do that, we'll call set result finish. So these two lines, what it does is it closes the current screen and goes back to the one that was there before. Okay, and here we haven't mentioned or we haven't loaded the value for the priority, that is the spinner, whatever the selection is from the user. We haven't loaded it yet. To do that, we'll override item selected method. Before that, we'll have to implement a listener. So implement start adapter view. Adapter view dot on item selected listener. So this particular listener will have two methods. So let's implement that on item selected and on nothing selected. So if nothing is selected, we can show a message to the user, or if something is selected, then we can use the array and load the value to the priority variable. So what is happening here is in priorities array, we have three sets of values, 1, 2, 3, 1 being the highest priority and 3 being the lowest. So if and when an item gets selected in the spinner, it will pass the position of that particular uh, spinner variables, high, medium, and low. And that particular position I'm using in the array and retrieving the that particular priority value. So this particular piece of code will set the priority as soon as the priority is set in the activity. So once this is done, you should be able to insert new task to the to-do list item. I mean the to-do list or whatever you're displaying in the main activity. And you should be able to add new data and you can go back and view it there. Right. So for now, let's take a short 5-minute break and then we can continue afterwards. So we'll continue on with the project now. So until now, what we've done is we've set up the databases and we've written code to retrieve all the data from the databases and to add new tasks to the to-do list. Right. So once this is done, the next objectives that we have is to delete the existing items from the database and then updating. Okay. So let's start with the deleting part first. So back in your main activity, we have made use of a RecyclerView and we have to delete those items from the uh, database. So we make use of something called as item touch helper here. So this particular item touch helper has two methods. Suppose when an item in a recycler view is moved and what to do, the code we have to write there. And if suppose the data is being swiped or the item is being swiped, what we need to do. So these methods are pre-existing methods. So we have to take care of that. So before we do that, so like I said before, we have to store the deleted value or the deleted item in a variable so that if the user wants to add it back by using the undo option, he can do that. So we've used this variable to store data there. And so let's start. Firstly, in this in your main activity, the parent layout is a constraint layout, right? So first, let's take the reference for that. So let's add an ID here before that. This ID is and constraint. Once this is done, we can write the code here back in your uh, sorry for that. So let's continue. So we'll need to have just added a reference to the constraint layout now. So let's uh, take a reference here. Constraint layout is equal to find view by ID r dot ID dot. So yeah, constraint. So once this is done, we also need a snack bar. So there are two kinds of messages that you can give to the user. One is a toast that we've already come across. Another one is a snack bar. So snack bar is a sort of a message that comes at the bottom with actions. So suppose you have deleted the item from the list. So you'll get a message at the bottom of the screen with the action. So if you click on that action, the value will be added back to the database. So to create the snack bar, we will the snack bar is equal to snack bar dot make. So this needs a parent layout passed to it. So we'll pass the constraint layout object that we just created, and it takes in a string variable. So we'll write task deleted, and then it takes the duration for which you want the uh, snack bar to be displayed. So paste transient of bottom bar dot length short. So it will the duration will be short and it will be displayed at the bottom. So if you want to add a action to it, in this case like undo method. So we'll just have to add the character sequence here, and then we'll have to add a listener to it, as if this particular action is clicked, or what should happen. That particular logic goes into this method. So what I said was, if the undo method is clicked, we have to uh, add the task, the deleted task, back to the database. So ViewModel has the insert method there, and we've already created the task variable here. You might ask me that the task variable doesn't have any value. So we are not uh, showing this particular snack bar until and unless our data is being deleted. So once that is deleted, this task value will be uh, instantiated, or the data will be added to this variable. And then when the user presses and clicks on undo, the task will be added back to the database. So to add the item touch helper, or to add the feature of sliding or swiping a recycler view layout, we'll use item touch helper. Touch helper is equal to new item touch helper. So we'll again pass a callback here. Item touch helper dot simple callback. So this particular callback takes two parameters. One is the drag direction and the swipe direction. So for drag direction, we can mention it as 0. And for swipe direction, we can, the user can either swipe left or right. So item touch helper left, or item touch helper right. So once this is done, the user can swipe the views. I mean, we'll still have to write the code to do what will happen when this view is swiped. So in on move, we are not doing anything. If it is swiped, only then we are deleting. So before we do that, we have to go back to our view model. Not view model. We have to go back to our task paging adapter. There we have to write a method which returns the state or task that is deleted. So we'll first have to return the position and then delete the item in that position. So if we can go back to the task list paging adapter file, there we'll write a method which will return the position for the task. Public task get task at position. So it will take a position as a parameter, the position of the list item that is being swiped, and then returns the task at that particular position, or the database variable at that position. So get item and pass the position. So this method will return a task variable. So back in your main activity, first we'll have to receive the position of the view that is being swiped. So we'll mention that as int position is equal to view holder dot get adapter position. This will return the position of the item that is being swiped by the user. And then we'll have to get the task variable at that particular position. So task is paging adapter dot get task at position and pass that particular position there. So this task is a create the global variable that we've created. So we'll populate it here, and then we'll have to delete this particular task from the database. So we'll use the ViewModel's delete method and pass the task to it. And here we'll show the snack bar. So once the view is being deleted, it will display it. So what the flow is, once the user swipes, we'll first take the position, and using the position, we'll retrieve the task variable, and then we'll pass that to the database's delete method, and then we'll display the snack bar, which has undo option and is being displayed at the bottom. If the user clicks on the action, it is the same task would be again inserted back to the database. Okay. So once this is done, we should add this particular item touch helper back to the uh, recycler view. So to do that, item touch helper dot attach to recycler view and the recycler view that we've already created. So once this is done, you should be able to delete tasks, right? So the next objective that we have is to update a pre-existing task. Suppose there are a list of tasks and you need to update. Let's say you want to change the priority. You've planned something for your day, and a more important task has come up. So you'll add that task as high priority, and you need to change the existing task to a low priority. So to do that, what we'll do is we'll click on uh, the to-do item that we have to change or update the value for. The same data should be loaded to the add task activity. So to do that, firstly, we'll make use of string extras. So let's create those variables here. So they are static and string. Extra. We'll be passing all the elements that are there in your that are related to a task variable. So in this case, there is ID and there is title, there is description, and last the priority. Let's just copy it and modify that. So the next one is task name or task title. Next one is description. The last one is your priority. So again, the string or the key that we are using will be in string format, but the ID itself is in integer format. Okay. So extra data priority. So once you mention this, we'll have two kinds of navigation. One is to directly go to the add task activity where you have to add a new task, or you can either go there to update an existing task. So in order to let the activity know what kind of operation you're performing, we'll have uh, two integer codes: private static final int. One is a new data. So let's give it as 1, and then we'll need one for updating value. Let's give it value as 2. The thing that needs to be mentioned is here. While starting activity, we're just passing the intent directly. Instead, we'll alter this so that the activity knows that if we are performing a update task or adding a new task. So let's remove the start activity and replace it start activity with result. Which takes in an intent under request code. In the case when you when the user clicks on a floating action button, we are adding a new task and not updating. So let's use the request code for new data. Okay, and then if suppose the user wants to click on the item, we'll have to pass the second code. So before we see how to pass that, we'll have to the logic here is we have to add listeners to the list items so that whenever a list item is clicked, the listeners get activated and then the code is sent to the add activity and it is pre-populated. The fields or the edit text that is there will be pre-populated. So to do that, we'll have to use our own listeners. So we'll go to the task list paging adapter and we'll write our own listeners. So to do that, firstly, we'll have an interface, public interface. Listener, which will have just one method, void item click, and it will take two parameters. One is the position of the item that is being clicked, and the view itself. After this is done, we'll have to give a method that will help the user set this particular listener in the activity or to the views. So to do that, firstly, we'll have to create a variable here, private click listener. And then when the adapter gets created, we'll have to pass the listener there. So here you'll have another method called set item click listener. So big void set on item click listener. It takes a click listener as a parameter. So here you'll set that listener. Once these two methods are done, we'll just have to make sure in your bind view holder that the click listener is not null. So to do that, we'll first check if the click listener is null. And then the view holder will add the listener. So holder dot item view dot set on listener, and then we'll pass the new view dot on click listener to it, inside which we'll call the click listener method that we've created. Click listener dot item click, and we'll pass the position and the view. We're receiving the position from the onBind view holder method and the view from onClick. Okay. So once this is done, we'll have to head back to the main activity and set up the listener there. So in here, we'll have to first create the listener. For the paging adapter. So task list dot paging adapter dot non-item click listener that we wrote, new, will by default return the paging list adapter click listener that we've written. And then here we have to mention what should happen when the item is clicked. So here what we'll do is we'll first take the item, retrieve all the data that is there in that particular list item. Current task is equal to, if you remember, we've already written a method that will return the task at that particular position. So do that. And then now what we've done is we are getting all the data from that particular list item in that particular position. The next objective is to load this data to the next screen, that is the add activity. So in order to do that, we'll first create a method to launch the update activity. So private void launch it, and it will take the task variable. So here what we'll do is we'll create an intent and we'll add data to that intent, and then we'll send it to the next screen. So what happens is, before what we were doing is when the floating action button is clicked, the user navigates to the next screen without any data being sent to it. In the case of update, we are sending some data so that the fields there will get pre-populated. Okay, so we'll create an intent here. We're calling this from the main activity. So main activity dot this, and we are heading to add activity. So add activity dot class. So once this is done, we'll have to add the data to the intent. So intent dot put extra. This works as a key value pair. So firstly, we'll have to mention the key that we've created, data ID, and using the tasks or entity class getter methods, we can retrieve all that particular tasks data like ID, title, description, etc. So intent dot put extra. The title, and similarly we'll do the same thing for description and priority. Start get priority. So once this is done, we can send this particular intent to the next screen. So again, start activity for result. In this case, we have data and update code. I mean the integer code to inform the next screen that there is particular data and there is a different kind of operation that is being performed. So once this is done, we'll have to go back to the add activity. In the add activity, here what will happen when the activity gets created, in case of update, we'll receive a data along with it. The data will be in the form of a bundle. So firstly, we'll have to retrieve that bundle and then we can populate the data. Okay, so first let's add that bundle code. Before we add the bundle code, we'll just copy these extra key items that we've mentioned. copy these and paste it here because we'll be using the same keys again to retrieve the data. Then we'll be retrieving the bundle first. So get intent.get extras. This method will retrieve the extras that is in the intent that created this particular activity. Okay. So once this is done, we'll first have to check if we are performing a update operation uh, or a new entry. So let's check if the extras is null. If the extras is null, then it means that the user wants to create a new task. So extras is, and if the extras is not equal to null, there is already existing data that needs to be updated. So first we'll retrieve the strings from the bundle. So task title is equal to extras dot get string. So we'll use the key that has mentioned here. So this particular get string method will make use of two parameters, either just a key, or we can even mention a default value if in case there is no such extra value there. So it will return a default value. In this case, we're just returning an empty string. Similar thing you can make use for task description also. So task description, and we'll make use of the key for description. So once this is done, we'll have to get one for the priority of the task. So we already have that variable for task priority. So task priority equal to extras dot. The priority is being stored as an integer, so we'll make use of the getInt method. So extra data dot priority. And the adapter is using the is accessing the values. The positions will be in the form of indexes, which is 0, 1, and 2. And the data that we have is 1, 2, 3. So just subtracting one value from that. So once you retrieve that, you'll just check if those values are empty. That is, if there is no values that is being sent by the bundle. You'll add a null check here, and if it is not null, then you can set the edit text or populate the edit text with the data that is being sent. So title text dot get text, and you'll pass the data there, task title. Similarly, for task description also, you'll do the same. Description edit text dot set text and pass the description value there. Task description string. So once this is done, we'll have to set the spinner item. If there is a value inside the priority, if there is no value, then it will be 0 by default. If it is not 0, then it means that some variable is there. So we will write if task priority is not 0, spinner so spinner dot set selection, and you'll pass the position there, which is stored in task priority. And you'll just make a UI change here. In case of update, we'll have to set the button as update and not submit. So submit button dot set text, and we'll write update here. So whenever the user wants to update, the button text will get changed to update string. So once this is done, we'll move forward with the listener part, where we've added the button click listener here. So in here again, we have to check if the extras is null or not. And if the extras is null, we'll have to uh, create a new task that we've already written code for. If the extras is not null, that is, it is an update operation, then we'll have to update it. So if extras is not equal to null, then first we'll have to retrieve the ID of that particular task, which is already being generated by the database. So long ID is equal to extra star get long, and then you'll pass the ID value to it, or the ID key. So we'll mention that. We won't pass any default value here. And then we'll create the task object with the data that we already have. So task is equal to new task. Firstly, we'll have the ID. Then we have the title and description. These values are being retrieved from the edit text and not the extras. So if you miss this particular part of code, your to-do list won't get updated. Okay, so and then we'll pass the priority. And then we'll use the ViewModel's update method, ViewModel dot update task, and pass this particular task. Else, if it is not a update task, then we'll just insert that. So while inserting a new task, our ID will be 0L because it will be automatically generated. For updating, we'll make use of the ID that is already generated. Okay. So once this is done, your updating database should work. Okay. So I think we've completed the querying part, updation, deletion, and insertion. So whatever the code that we have right now will work for those 4 parameters. So since we have a little more time, let's talk about how to pre-populate the database. So to do that, I mean, for this particular project, it doesn't make any sense to pre-populate. But suppose if you have any other application like your college contacts application that has pre-filled data, then you'll have to pre-populate it, right? So we'll have to use an assets folder there. So let's create one assets folder. So once it is created, we'll have to add a file there. So in this case, in this particular case, we're making use of a JSON file. It has JSON the data in terms of in the JSON format. So as you can see, we have around 4 objects here, JSON objects. So we'll have to parse it and we'll have to pre-populate in the database. So to do that, we'll go to the database package and task database. And here we'll have to create a method to populate the database when it gets created, right? So let's do that. So we'll write private. Okay, when you create a assets folder, your Gradle file will get recreated. your Gradle will get resynced. So once it is done, you can start working. So yeah, now it is done. So let's write the method private void static void pre-populate database. So this particular database will take this particular method will take your set manager. So if you have any files that you want the user to use, we'll add it in the asset folder. So we'll need an access to that asset manager and to insert it to the database. In the database task database class, we'll need access for the DAO. So once this is done, we'll be reading from a file. So we'll need a buffered reader. Let's set it to null. And then we'll need a string builder so that as and when the buffered reader reads the file and the input is being it will input is being read. So the entire input will be appended to a single string using string builder. So new string builder, and we'll need a empty string for JSON. So the string will have the entire once the reading process is done, this particular string will have the entire JSON data in the form of a string. Right? So let's start reading. So inside, we'll do this operation inside a try catch block. If in case there is if there is any error, the catch block will take care of it. So buffer reader, first we'll initialize it. New buffer reader. It will take a new input stream reader as a parameter. So here we have to mention the name of the file that we have in the assets manager. So asset manager.open, and we'll mention the file name here. In this case, it's to.json. And then we'll have to read from that particular file. So string line file buffered while it is being read. If there isn't any null value, that is, if the file hasn't reached the end of line, continue to append the data that is being read to the string builder. And once all the data is being read, then just convert that string and store it in JSON string. So string builder dot toString. And once this is done, we'll write a catch block here. If in case there is an IO exception, so after this is done, once the entire entire data is being read from the JSON file, we'll have to give up the resources. So we'll close the buffer reader there. So if buffer reader is not null, that is if it's still active, just buffer reader, it will be closed here, buffer reader dot close. Inside the catch block, we'll have to IO exception. dot start trace. So once this is done, the data is successfully fed into the JSON string. We are yet to parse it, so let's start doing it. So to parse JSON, we'll do that again inside a catch block. First, if you can see the data here inside the JSON file, the whole thing is in form of a JSON string within which there are multiple arrays. I mean, there's an array element which will have multiple JSON objects. Right? So the first priority for us will be to create the JSON object from the string. So JSON object is equal to new JSON object, and we'll pass the string here. The string is stored in a variable called JSON. So the error here is that there is no catch block added. So let's add that. So once this is done, from this particular object, we'll have to retrieve the array called to do. So to do that, you can write JSON array to do is equal to JSON object that we just created here. From that, we'll access the array. Get JSON array with the name of to do. So this will return the JSON array that we have here in the to-do list file. This particular to-do array, JSON array, has 4 objects, JSON objects. So we'll need to pass that again. So let's make use of a for loop. For firstly, we need to retrieve each element inside that array. So use the, just mention this as to do's, and here I'll mention it as a single to do. So JSON array dot get JSON object at the index I. So this will return that object. So we'll have string title is equal to true dot get string. In while JSON parsing it will be in the form of key and value. Okay. So we'll use this key to access this value. So title, content, and priority. So for title, we'll have to mention the key called title. And then we'll need to take the string for description. And lastly, we'll need the priority. So yeah, this key. And then we have all the objects, all the data that we need to create a task. So if you remember, while creating a new task object, we will pass the ID as 0L so that the database creates an ID for it by default. So we'll pass 0L as the first parameter, title, and then description, and lastly the priority. So we have the new task item created here. Now we have to insert it to the DAO. So task DAO dot insert task. Once you pass this particular task there, the to-do list item will get inserted. The same thing will repeat for the different number of to-do list item we have. So once this is done, we'll have to call this method from the callback, and that too inside a executed so that it works in the background. So pre-populate database, and we'll have to pass two parameters to it. One is the assets, and then the task DAO. So context.get assets to get access to the assets folder, and then we'll have to pass the task DAO to it. So we'll say instance that is the database that was just created, and we use the task DAO inside. So once this is done, if you install your application, you'll have pre-populated data there. And yeah, so I think this would be enough. So if you're receiving data from a REST API, then you'll have to create a retrofit instance, or you can parse that JSON data using JSON parsing and JSON parsing methods, and that will be again run in the background threads. Or you can instead use something called as retrofit, which is out of scope of this particular session. So this is about the to-do list item or the to-do list project that we had. Before I end my session, I would add on some more points for new developers so that it will help them in going forward, right? So wait a second. So you can see the screen here. Firstly, coming to the UI and UX design. UI UX design, it's not just design, it interacts with your users' psychology and how it helps you maintain or retain users. And obviously, an app with really bad UI, but has some good features, won't work well with the users. So what Google has done is it has launched its own design system called Material.io, similar to the ones like even Apple has its own, and even Microsoft have their own. So Google has launched something called as Material.io. This particular uh, web page will help you a lot in designing. It has design guidelines, use cases, a lot of tools like palette select or to select colors for your views, and how you can make use of material components like a material edit text or a material floating action button. These components will obviously increase the way that your UI behaves, and it will make your UI look really good, right? So you can check out this particular page, which has everything that you need for uh, creating a really good UI. And it's not only for Android developers, even Flutter and web developers can make use of this particular page. The second one is the Android official documentation, which is really important for new developers. I would suggest you just take a look at this particular web page, which has everything that you need, how to build applications for Android TV, smartware, and other stuff. Everything that you need. The updated code will also be there. It's not just theory, you will also have code snippets wherever you need, so that in future, if you want to build something on your own, then you can look up the documentation and do it on your own. Okay. And also it has references to Kotlin and Jetpack, which is a new library. So once you're through with it, and once you're ready to launch your application, the process is like this. See, until now we've coded into a test application or test APK. In Android terms, we call this as debug version. If you can see inside your Android Studio only, to your left, you'll have something called as build version or build variants. This particular build variant, there are two types of build variants. One is debug, and the other one is release. So if you want to launch your application, if it is ready, you'll click on release, and your release version will be ready, and then you'll have to sign the application. Signing as in every developer will have a unique key or unique file store or unique key that they will use to sign their APK, and this particular signed APK will be launched. And the process to launch your application is to firstly you'll have to purchase a Google Play Console account, which costs around 1,500 or 1,600. So in order to create that, you'll have to have a credit card and an account. And once this is done, you can create your own account. And there you will have to, in order to publish your own app, you can go to the publish section, and then you'll have to give a release version APK which is signed, which is jar signed. Okay. And then if you want with that APK, you can either put it into alpha testing or beta testing, or you can launch the app for users to use, right? And to launch the APK, you'll need to have a high resolution images of or screenshots of your app, a minimum of 4 to 7 screenshots of different UI features inside your app or the features that you are promoting. You can also have a promo video of your app, and you should have a high resolution picture of your app's icon. And then you'll have to obviously have the APK that is there. And apart from that, if you want to add your own privacy policy, you can add a policy also there. And to monetize, the next part is how to monetize your uh, what do you say, your app from users. So in order to do that, we can make use of AdMob. So it is again from Google itself. They have code snippets there. If you just create an account in AdMob, you can they'll give you code snippets and how you can add ads in your app and monetize from your applications. So that support is also there. And from Android 11, they and from this particular year, they've made a lot of changes to Google Console so that it becomes easy. And the next and the last part is Firebase. So if you're working with Firebase, your uh, app can have multiple features. See, Firebase itself has a lot of features like authentication, storing database in a real-time database, and if someone asked a question regarding machine learning, so Firebase has its own ML APIs like image detection or text detection APIs. You can also host your custom models inside here, inside the uh, Firebase ML kit there. And then you can, based on the region or different kinds of parameters, you can uh, let the users download this particular model into your phones and use it. Apart from that, it also has testing, add how to add the ads into your app. There is analytics which will give you how your users are working, and then there's in-app messaging. If you've seen a few apps where they'll promote to users who are active. In the case of food delivery apps, you'll probably, if you're active on a particular days on Sunday, you'll receive a notification from the developer saying, or there's an offer on this particular item. So in order to engage and increase your app users, you can make use of in-app messaging. And this particular thing for people who are learning application development, you can make use of it for no cost. Once the limit exceeds, that is, once the storage limit exceeds, then you'll have to pay. All right. So that is about Firebase. So I think we're done for today's session. If there are any questions, please to ask in the comment section. We'll be happy to answer that.
I guess a person was asking a doubt on I guess the same person who asked it out earlier this afternoon. So you need a little reference for this.
All right. So in order to deploy your model, you can use Firebase. Like I told, you can host your model there. Or if you want to if you want to add the model directly to your application, then you can import it using the TensorFlow Lite. And I mean, in the new updated version of Android Studio, you can import your TensorFlow Lite models directly. If you want reference, go to uh, currently there is something called as 11 weeks of Android going on. All the new features are being explained, and there are a lot of code labs. So I suggest you to go to that code lab and try that out first, and then you'll get a brief idea of how you can import a custom model and use it.
Okay, I guess that's it from the doubts. I guess there'll be further doubts after this live session when people watch this video later. So I hope you can spare time on addressing these people's doubts.
Sure.
And is that it? Will Adith be speaking further?
I think that'll be all.
Okay.
Yeah, that's it.
So thank you guys for conducting such a well-described code workflow as well as quick tips on how to improve in the field. And we really thank you both Aditya and Ruthvik for being a part of this. And we also look forward to working with you
Thank you.
in future events.
Thank you, Kevin, and we'd also like to thank Usha ma'am for this wonderful opportunity, and Usha ma'am from our college who supported us throughout. So yeah, thank you all of you.
And and to the audience here, I'd like to thank you all for watching this video. I knew it was, thank you for sparing your weekend time on watching this video. And I hope you guys are doing well. And we have future events coming up. We also have events coming up next week. We have put up the links in the comment section as the first thing. It's a Google slide link. You can check out if you want to talk to us or want to volunteer or something. You can just check out that link, and please stay tuned for further events. And goodbye for now.